Okay, for this problem, we're going to find the area of the surface generated by revolving the curve y is equal to the square root of 2x minus x squared from 0.25 to 1.75 about the x-axis. Okay, I've got the formula written out here. I've got our a and b here. Keep in mind that y and f of x are the same thing, so we've got f of x is equal to the given function, square root of 2x minus x squared. Take a quick derivative here using the chain rule, and that will be, let's see, bring down the 1/2, and then the inside will give us 2 minus 2x is the derivative of the inside divided by 2 square root of 2x minus x squared. Okay, so let's plug into this formula here. So we have s is equal to the integral from 0.25 to 1.75 of 2 pi, the function, square root of 2x minus x squared. And then, of course, we have the formula that has a square root as well. Square root of 1 plus the derivative of f of x squared. Here's the derivative of f of x. So we have, oh, you know what? Let's clean this one up over here. We've got a 2 that can be factored out on top, and that will reduce with the 2 on bottom. So that's actually 1 minus x over square root of 2x minus x squared. That'll make this a little easier over here. Okay, so let's go ahead and put that in. 1 minus x squared over the square root of 2x minus x squared. Okay, and that entire thing will be squared, actually, not just the top. So let's take this out and put a square around the entire thing. Okay, so when we square the top, it'll be 1 minus x squared, 1 minus x quantity squared, and then the bottom, the square root will cancel. So let's pop down here, a little lower end, rewrite this. So s is equal to the integral of 0.25 to 1.75 of 2 pi, which is square root of 2x minus x squared, and then the square root of 1 plus, and well, let's keep that as 1 minus x for now in this step, squared. And then the bottom, the square and the square root will cancel. That'll give us 2x minus x squared. Okay, so on the inside of this, the second radical here, let's go ahead and combine the 1 with this fraction here through common denominator. So 1 is the same thing as 2x minus x squared over 2x minus x squared. So in our next step, let's go ahead and write all this down again. Okay, so we will have 2x minus x squared. Let's go ahead and distribute this out. So that will be 1 minus x, let's put that plus there, plus 1 minus x plus x squared. And since we have combined those, that will all be over 2x minus x squared. Okay, so this right here, in case you're confused of where this came from, 2x minus x squared over 2x minus x squared is this 1 right here. Okay. So if you notice, we've got a 2x, but we also got these terms here that cancel it out. We've got a negative x squared, a positive x squared. Okay, so that's all going to cancel out, and we'll get basically just a 1 on top. Okay, so I'll write that in my next step. S is equal to okay, so we've got the square root of, sorry, that was my phone that went off, with the square root of 1 over 2x minus x squared dx. Now we can distribute this radical into this radical, and these two terms will basically cancel out and be left with just a 1 or a 2 pi basically. So all this is going to cancel out. Once we multiply this through, this will cancel with this. It's all gone, and we get s is equal to the integral from 0.25 1.75 of 2 pi dx. Okay, when we actually take that integral, we will get 2 pi x 0.25 to 1.75. Let's go ahead and pop that in real quick. Our limits, so 2 pi And we'll have 1.75 minus 0.25. And that's going to actually give us 3 pi is the surface area. So the surface area generated by the curve is 3 pi.